Okay, we'll get started in today's topic. We're going to talk about flow control and writing functions. We're going to start moving into the idea of programming in R. And in last lecture, we started the topic of subsetting, but we ran out of time, and I'm going to have to just leave it to you to do your reading on the topic of subsetting. And to see how that works out. Just because, in the interest of time, there are other topics that I want to kind of make sure we cover in class. I do think, and I'll post some additional notes on subsetting, but they're very much adapted from Hadley Wickham's text. So I would say, I recommend reading the textbook Advanced R's chapter on subsetting, which I think is excellent. And a good way for all of this stuff is to actually he uses a lot of code examples in his textbook, and I recommend typing those code examples yourself into the computer and then kind of just playing around and just, see if you can modify some of these subset examples, okay? You should have seen the first homework by now, and this first homework assignment is pretty easy. So get your points on it. 100% should be no problem. Okay. All right. So we're gonna just get started with basics in programming here. Okay. And so if you're not familiar already, you'll definitely want to set a working directory in R. Okay, so anytime you read and write to files in R, so if you're using any kind of command that tells R to access a local file or anything like that, it's going to start by looking in your working directory. Okay, and then if you have any outputs, it's going to save them to your working directory, and so you'll want to specify that. Okay, it's quite easy to do. So if you're doing an R script, you can use the command set working directory or get working directory. Okay, so if I just type in here get work, whoops, I have caps on, get working directory, it will say I'm working in that folder. Okay. And you can set working directory, and you can type out a path, okay? And one thing about R is that if you're on a PC, the backslash is an escape character, and so you'll need to do either double backslashes or forward slashes, okay? You can always, if you prefer not to type out the path, you can do session set working directory and choose a directory this way, okay? And this is kind of more graphic friendly, but if you're gonna write some code, it's often nice to have it kind of hard coded in there, just so you can kind of queue up your script. Okay, so that's your working directory. Of course, anytime you write code, it's a very good idea to write comments in your code. And so the way you comment out things is using the whatever symbol you call this, the pound sign or the hashtag, but they're not hashtags, just hash marker. And you just say, this is a comment, and it won't be evaluated by R. Okay, and so and it's the useful way. Another useful thing is to disable lines of code as well. You can just put a hash in front of that line, and it will prevent that code from being executed. So here we've assigned 3 to x, and then we would have assigned the number 4 to x, but because we've hashed it out or commented out, x gets evaluated at 3. Okay. If you, anytime you do stuff in R, sometimes you'll have stuff in your environment. So let's say we have x is 4 and dj is 90, okay? And then I run these things, okay? So now I have stuff in my environment, okay? If I want to clear it out, I can remove these things. I can say remove x, and it removes x from the environment. Or another quick way to do it is just to remove, and you say list equals ls. And what ls does is it lists off everything that exists in the environment. And then so you can just tell R to remove everything that is listed off in the environment. Okay, and that's going to clear everything out. Optionally, you can do it using the buttons here. And you just click the the sweep button, which will remove all of the objects from the environment. Okay, and another way is if you don't want to individually tell R, I want you to remove this, you can change it from grid to the view mode to grid, and then you can say take this thing and remove this one object, and it will remove that one object. Okay, so those are just ways to clear out stuff here. Okay, so removing x will remove the variable x and list things out. Okay, and so whenever you start a new project or something like that, it's a good idea to clear the environment. Okay. I strongly recommend writing your source code into a a script document over here. Okay, and so you're going to go file, new file, and new R script. This little button right here will do it also. New R script, and you can also create other things as well. Rather than just writing things directly into the console. The console is useful if you want immediate feedback on something, but it's probably better to what's going on here? It's probably better to write your stuff here and then run it. Okay, so whatever commands you might want to do, you can run here. So if you want to just assign values, A is 65 and B is 23. You can run all of these things. You can highlight them. Okay, you can highlight each line and hit Control Enter, or if you just hit Control Enter, it will just run through the script there. Okay, these are all just nice little features of RStudio. Okay. Okay, so we often will use conditionals to program our functions, or program whatever it is that we want to accomplish. Okay, and so these are logical operators. This is the or, this is the and, this is the not, and this is a non-vectorized or and a non-vectorized and we'll talk about this. This is an exclusive or, and this is true. Is just it's a kind of a logical test here. Okay, and so as far as operators go, I think you guys know how these things work, but we'll talk about them. So basically, if you're using the and, both statements x and y have to be true for it to return a true value, and then for the or, it's either x or y or both can be true, and it will return a true. Okay, so the and requires both of them to both be true in order for the thing to return true, and this will be just one of them has to be true. At least one has to be true. Okay, so for most of the time you will use the single and or the single or. Okay, and these are vectorized, meaning that if you give it a string or vectors, logical vectors, it will perform recycling and do kind of these comparisons element-wise. Okay? The double or the double and, this will only look at the first element of a vector. Okay, so if you give it a vector with multiple items in it, it's only going to look at the first one. And this, we recommend using this when you are using if statements. Okay, because if statements will only look at one thing in there, and so it makes sense to use this because it's only going to look at kind of one thing. All right. And then the exclamation is the opposite. Is the not function. Okay. Numeric vectors. So numeric values will be coerced to logical if you feed them into an and or an or function. Okay. Where anything where if it's a 0, it's going to be false, and anything else is going to be evaluated as true. Okay. So let's take a look at what this does. All right. So here's true, true, false, false, and here y is false, true, false, true. So if I do the vectorized or, it just says, okay, true. It looks at the first two, and it's going to evaluate true. It's going to look at the second two. It's going to evaluate true. It's going to look at the third pair, and that's false. And it looks at the fourth pair and evaluates true. Okay. However, if I use the non-vectorized or, it's only going to look at the first element of x and the first element of y, and that gets evaluated as true. Okay. Same with the false and with the and. It's going to look at the first pair, second pair, third pair, and fourth pair and evaluate and accordingly. Whereas if I use the non-vectorized and, it only looks at the first pair and evaluates that as true or false. Okay. The exclusive or is either x is true or y is true, but not both. Okay, so that's the question. Do you like vanilla or chocolate ice cream, and not do you like vanilla or chocolate ice cream? Okay, so because in English the or is ambiguous, right? So we have the exclusive or where you have to kind of choose one or the other. So in this case, one has to be true and one has to be false, and that's going to evaluate as true. But if both are true with the exclusive or, it gets evaluated as false. Okay. The is true is an abbreviation of this command, identical true x, and it's only going to evaluate for true if x is a length 1 logical vector whose only element is true and has no attributes. Okay, so if it's anything other than a length 1 vector that is true, it's going to come out false. All right. Okay, and then we have comparison statements for numeric values. Is x greater than y or less than y or less than or equal to y, and so on and so forth. Are they equal to each other? Are they different from each other? And is x contained within some vector y? Okay, and these are all vectorized, meaning you can feed it more than one item inside the vector. Okay, the vectors can be longer than length 1, and it will do element-wise comparisons. Okay, and so and then of course when you do these comparisons, what it returns when you compare two numeric values, it's going to return true or false depending on it. So the inputs will be numeric values, and the outputs will be logical trues or falses. Okay, so all of this is useful when we are trying to perform kind of control the flow of what gets evaluated in some kind of programming statement. Okay, and so kind of most useful is using the if statements. All right, and the if statement expects a length 1 logical vector that is not missing, okay, is not an NA. So it's going to have to be either true or false. If inside the if statement that the function that's, or the statement that's being evaluated in the if function, if there's more than one, only the first element's going to be used. Okay, and so that's why we recommend using the non-vectorized, the double or the double and for if statements. Okay. Other things get coerced into logical statements if possible. All right. And then after the if statement, if it's true, you will have a curly brace that that contains the commands that will be evaluated if what inside the if statement is evaluated as true. Okay, and if there's only one expression, then the curly braces are optional. Okay, so we can say x is the vector 1, 3, okay? And we can ask the question, is 1 in x? And it's going to evaluate true, okay? And so then we say, if 1 is in x, print hello. And so when it runs this, it evaluates this. This gets evaluated as true, and because it's true, it's going to evaluate the next statement, okay? And if it were false, it would skip over the statement, okay? And because there's only one thing to execute, we didn't include the curly braces. But if you want to include the curly brace just for this one line, that's fine, okay? And so it's going to print hello. All right, how nice. All right, over here we can ask, we can say x is same vector 1 and 3, and we ask, is x greater than or equal to 2? And so that's going to return a vector, false, and then true. Now if we were to feed this inside an if statement, it's only going to look at the first element here, okay? Whoops. All right, and so what happens is that it looks at the first element, false, so it does not execute this line, okay? This line is not executed because it's false. And it also gives us a warning, and it says the condition, which is x greater than or equal to 2, is has more than one element, and so I'm not sure if you meant to do this, okay? So it gives you a warning, but it doesn't error out. It'll do what you asked it to do. But it says, are you sure? And then that's it, okay? But again, because it was false, this thing doesn't get evaluated. Okay, there's a command any, which basically it looks at all of the elements within a vector, and if any of those things are true, then it's going to return true. It's like the any is kind of like the super or, right? So or is, you know, if either of two elements are true, it's going to return true. Any is kind of like you give it a vector of 20 elements, and if any of those things are true, one or more, then it's going to be evaluated as true, okay? And then so here, we throw that in here. If any of x are greater than or equal to 2, then will you evaluate this? And it does, okay? It evaluates, it says this is true, and it evaluates it, and you get that, okay. All right, we can nest conditionals, so you can imagine some kind of flow path where you know, you got the if, where if it is true, it gets evaluated, and if not, it goes down another path, and so that gets handled with else and else if. Okay, if you're going to so you can say here x is equal to 3, and we're going to ask, is x less than 0? If it is, print negative. Otherwise, if x is greater than 0, print positive, and then finally, if that's also not true, else print 0, okay? And so when it goes through this, this gets evaluated as false, this gets evaluated as true, and so it prints out this, and then it kicks out, okay? If it goes false, false, then this last thing will get evaluated. Whenever you do an else if, make sure that if is on the same line as the else, okay? Otherwise, and then you also have to put the else on the same line as the closing curly brace, okay? Because like if I got rid of these curly braces here, what would happen? Whoops. Ah. Can I copy that? Okay. So here I'm going to set x equal to 0. What happens if I delete these curly braces? Okay. Will it work?
Will it not make a difference because there's only one command for each state?
Yeah, so I'll show you what's going to happen. Okay, so we got x equal to 3, and then I'm going to run if x is less than 0, print negative, okay? And what we see is that R thinks it's done, okay? R thinks it's done because there is now, it gives me this sign, the prompt, meaning it's ready for more stuff, okay? So because there was only one command and there were no curly braces, it just says, if x is less than 0, print negative. Well, x is not less than 0, so I'm not going to print that, okay? And if I try to run the next thing, it's going to say, what do you mean else, okay? There's, you need a starting if statement before you use an else, okay? And so so when it finishes this thing, it thinks we're done, and then so when I say else, it's like, what are you talking about? There's nothing else to talk about, right? So you have to include this, and this will say, okay, first do the if statement, and then if that doesn't work, then evaluate the next one. So if you're going to use else's, you've got to use the you have to use the curly braces. Okay, so here this will work. Okay, and then I mean this last one I don't have to use the curly brace. It'll technically work, I think, but probably for good style choices, we should do that, right? Okay, and so by using the curly braces, it allowed us to continue feeding it. Whereas before, without the curly braces, it thought we were done after the first if statement. Okay. Okay. Continuing on, doing the same thing with x equal to 0. This gets false, false, and so this last one gets evaluated. Okay. Okay, if we set up our thing this way, if x is greater than 0, and then we have an else if x is greater than 1, otherwise, print not positive, this thing doesn't get evaluated because this is true, and so it's not going to evaluate any of the else's, right? Because we say, if you can do this, do it. Otherwise, do something else. And you're only going to do that otherwise if the first statement was unsuccessful, right? So it's not going to get evaluated there. Okay. So watch out for stuff like this. This is probably a good thing to test you guys on. All right. All right, so now let's take a look at loops. You're probably familiar with loops, but we'll take a look. Okay, so we have the for loop. All right, and what you do with a for loop is you feed the for statement a vector, okay, and it's going to evaluate the whatever command is in here for every element in that vector, okay? So it's going to say, what we're feeding it is the vector 1 through 10, and then we're going to say for each of those items, 1 through 10, and each item is going to be called x for x and 1 through 10, square that thing and print that out, okay? And so that's what we have here. Yes, question?
What's the scope of the variable x that's inside the for statement?
What do you mean?
Where else is
It only exists inside this this statement, unless you well, if you have an assignment inside for to another variable, then it will exist outside of the for. Okay, yeah. But yeah, the x here only. So here we'll. So here I'll clear my workspace here. Okay, so when I run this, no, I'm sorry. I guess x does get created inside with the for statement here. Okay, and so yeah, x gets evaluated there. We can also, inside this, I can say y is going to be x plus 1, all right? And then so if I run this, it's going to create a y. So yeah, x gets created and it exists outside of the loop. And it will, I'm pretty sure, will overwrite. Yeah, so we can if you have x is equal to 0, but then you run the loop, it will overwrite that x there. Okay. Okay. So here, L, we are giving it a list, 1 through 3, the letters 1 through 7, and a vector of character vector and a logical vector. Okay. And then it's saying for y and L, and print out the length of y. Okay. And so what, if we look at L. Okay. So if we ask what L is, okay, we see it's this list with 3 items, 7 items, and 2 items. Okay, and so when we ask for the for loop to print this stuff, it's going to print out 3, 7, and 2 because we're asking print the length. And it's not printing out the individual things because it's just kind of looking at the first level of hierarchy in the vector that we're feeding it. Okay. All right. Let's take a look at this if-else stuff. It says another useful conditional is the if-else. Okay. And so we can run something like this: if x is equal to 5. Put in n is store yes as n, otherwise store no. Okay, this thing can be reduced to this. Okay, and it's just if else x equal to 5, yes or no. So it's just a shorthand way to get this exact type of thing. So just if you're gonna do a short thing, so what it does is it's going to return yes, but notice the assignment is done outside of the if else. Okay, so if else, it's going to return yes and get stored into n. Okay, whereas over here we are assigning the value yes to n inside the statement to be evaluated. No, that was a funny glitch. Okay. Okay. Oh, so here, if you're gonna run a loop where you're storing the results, okay? So here we're kind of combining the subset operations here, okay? And so here I've created an object called results, or res, short for results. And first we're creating a vector of length 10, just full of missing values, okay? A vector of length 10 with missing values. And then we're going to say for x in 1 through 10, evaluate x squared and store that in the results vector in location x, okay? So the first time it runs through, it's going to have, it's going to subset the results vector to 1, the first element, and then the next time it runs through, x will be 2, and it will subset the results vector to the second element, and it's going to store all of these things as we go along, okay? It's best to have the results vector defined in memory first so that it will place it in its location rather than growing the object as you go. So the other option is I didn't define the results vector. I just created an empty vector called results, and here what I'm doing is I'm saying we're going to just combine the currently existing results vector and tacking on x squared, okay? So the final result is exactly the same, okay? But every time we run this, it's gonna, what it is doing is it's copying the entire results vector, tacking it on, and storing it as a new results vector, okay? And this is computationally inefficient, and so it will slow down our evaluation, okay? This method is also bad, where I just defined results as 0, and I'm saying store the first element or into the second element or 10th element. Every iteration, it requires that the results vector is resized, okay? And so all of these things, when you're doing x in 1 through 10, it's not going to make a huge difference, okay? But if you did x in 1 through 1,000,000 or something like that, x in 1 through 100,000, for if you're doing some kind of like bootstrap sampling or something like that, where you require lots of repetitions, sometimes these differences make a difference in the amount of computational time it takes, okay? So so it is generally a good idea to have the anytime you're going to be writing to objects outside, to have those defined. Okay, we have other ways of defining loops. So the for loop, you're giving it a vector, and it's going to run through every element in that vector, okay? And most commonly, the vector that you give it is like an integer, one integer vector like 1 through 1,000 or something like that. But you can have other loops, such as while loops, okay? And here we're basically doing something similar, and it's, we give it an initial value, I is equal to 1, and then as long as this thing is evaluated as true, it's going to run through the commands inside the loop, okay? So because it says, so as it kicks out, so it always evaluates this, it runs through this, it evaluates it, and then when this thing gets evaluated as false, it will kick out, okay? So it evaluates this. If it's true, it evaluates these expressions, and then when it gets evaluated as false, it kicks out, okay? So here we have this, and so I is moved up, and then it increments I, okay? If you don't include something such as incrementing I to another value or something like that, you could get stuck in an infinite loop, right? Because it's going to just keep evaluating this thing as true. So if you don't change some of the things inside the loop to where it could eventually cause this thing to be false, you're going to be stuck in an infinite loop, okay? On the other hand, the repeat is kind of like the opposite of a while loop, where it's just going to continue to repeat all of the actions until it receives a break command, okay? And so here it just repeatedly evaluates this thing, and somewhere inside the repeat loop you need to include a conditional that says if this thing is true, break out of the loop, okay? So it says if I is greater than 10, then break out of the loop, and that and then we have that, okay? And so just depending on your situation and maybe your stylistic preference, you might choose to use a while loop or a repeat loop or things like that, okay? When you're reading other people's code, which is going to be very often, because rarely will you be coding everything yourself, you'll often look at you know, packages or things that have been written, and maybe you want to tweak something yourself, okay? When you look at other people's code, they might use a repeat loop or a while loop, and it's important that we can understand those. Even if you yourself, the only type of loop you ever use is the for loop, that's fine, but if you want to be able to read other people's code, you got to know these other loops as well. Okay, the break will end the innermost loop. So if you've got like loops nested inside other loops, which in general is not recommended, R is not, you know, there's no compiler, so it doesn't try to find efficiencies for handling loops and things like that. So, you know, loops within loops, it's fine, but may not be the most efficient. Break will break out of the innermost loop there. And then next just ends the current iteration and moves on to the next, okay? So it says, you know, for I in 1 through 10, if I is if I mod 2 is equal to 0, meaning I is divisible by 2, then break out, okay? And so it evaluates I at 1, and then when it hits 2, it quits, okay? And here it says if I mod 2 is 0, if it's even, just skip to the next iteration. So we're using next, and so it skips all of these all of the even numbers, okay? And so we get printed out 1, 3, 5, 7, 9. Okay, we have sequence along, all of these other things, okay? And so these are so sequence along is kind of like, so normally, whoops, when you do you know, x in, most often we see for x in 1 through 10, or for x in, and you give it some vector here, okay? So we might say for x in L, okay? For x in L, and it will go through each element in L. What I've replaced L with is sequence along L. And basically what sequence along does, so here I've got L, and L is this list here. And what sequence along is basically it's you know, 1 through length of L. Okay, so basically we're doing you know, what is the length of L? And it says 3, and basically we're asking do 1 through 3. That's what sequence along does. Okay, so if I have D is, we'll do 3 through 15. Okay, so if we ask what is D, which is this, sequence along this, sequence along D is going to give me 1 through 13, which is essentially the same as asking what is the length of D, and we're going to do 1 through length of D. Okay, so sequence along is kind of like a shorthand for 1 through the length of whatever thing you're feeding it. Okay, so that's what we've got here. Okay, for x in sequence along L, this is basically for x in 1 through 3, store in the results of x the length of L subset this is the list subset X, right? Okay, and I know we didn't cover the full subsetting here, but we've got the double bracket for the subset because it's a list to indicate that we want the stuff inside. So if you think of the list as train cars, the double bracket indicates we want the contents inside the train car, not the train car itself. Okay, oh, and this is exactly what I was saying. So 1 in length L is 3, right? So 1 through 3 is that, sequence along that is that, or sequence along length L. Okay. Sequence length is basically 1 through 3. So these are all pretty much equivalent here. Okay, so all of these things that we've done with loops could have been accomplished with subsetting or using apply or even vectorizing our functions, okay? So you know, we ran a bunch of loops where it's like for, you know, I in 1 through 10, you know, in the results of I store X, I'm sorry, I squared or something like that, right? Yeah. Okay, and then we can ask what is the results, and we get all of this stuff. Now probably the best would have just been what is 1 through 10 squared, okay? And this will evaluate much faster. So I mean, for example, if I did you know, if we ask the CPU runtime for stuff like this, you know, these vectorized approaches will be will generally be much faster, okay? So a lot of times it's good to think, how can we vectorize the code to avoid loops, okay? And I strongly recommend that you try to think of things in vectorized form rather than building loops. But, you know, thinking time is hard, and computer time is generally cheap, and so a lot of times it's okay to write some inefficient code and then work on making it efficient later. But I do think it's a good idea to try to vectorize code, okay? And sometimes you can't think of ways to vectorize the code, and you got to write loops, okay? And that's fine, okay? So, you know, for example, what if I wanted you to create a times table? So, you know, like we got, we'll say x is 1 through 10 and y is also 1 through 10. And let's say I want to create a matrix with, you know, kind of like your times table that you had in elementary school, okay? You can do, and you can say like for I in x, okay? And then you would have to then do a loop for, we'll say j in y. And then we'll create a results matrix. Will be I'll do create a matrix where we've repeated NA 100 times, okay, with a number of rows equal to 10 and number of columns equal to 10, okay? So we've got results matrix, and then we can say results underscore matrix I comma j, and we're going to store x times y, all right? And this will work. Did I mess something up? I did. Oh, yeah. I times j, thank you, okay? So this will subscript out of bounds x. Let me just see, what am I doing? Okay, so I got results matrix All right, and then I want I in X for J and Y, results matrix, I comma, am I missing something here? Value is equal to 110, subscript out of bounds. So let me think. Oh, I never executed this. Okay, then now it'll work. Okay, so I never actually told R what X is, and then so I can ask what is my results matrix, and we have our times table. Okay. This is fine. This is rather inefficient because you've got a loop within a loop. It's much better if you can learn a little bit of vocabulary and you can just do outer, and you do X, Y, and you give it the you give it the multiplication command, okay? Or you can just do X star O star Y, okay? And so these are just kind of like vectorized forms, and this is much faster, okay? Faster ways of evaluating this stuff. So, you know, a loop within a loop, as you know, it would especially be inefficient if we had, if I did 1 through 10 to the 4th or something like that. Because this will now be 10 to the 8th, and it will take a long time. Number of rows, 10 to the 4th, 10 to the 4th. And if I ask for this, it might, of course, X, Y. Okay, and so you can see, I think it's running. Did I mess something up? Okay, well, it's going to take a long time, whereas the I'm breaking my computer here. Whereas something like this, if I just if I called this result matrix here, it'll evaluate much faster. Okay, so it's already done there. Even though this is you know, something with 100 million elements in it. Okay, it evaluated fairly quickly. Okay. All right, so you know, vectorized versions of our code probably better, or you know, and matrices are pretty much vectorized versions as well, because R just handles matrix as an atomic vector with dimensions. Okay, why don't we take a 5-minute break here, and